Hi and welcome to video 5, Unit 4, Topic 1, Second Derivative. We're looking at optimization and I'm going to start video 5 with example 5 and then we're going to roll into a heap of videos with single examples of optimization questions, starting with a few area volume questions as they seem to be the most common, particularly at a simple familiar level. So area and volume, and don't forget you've got a formula sheet and your formula sheet contains all of those pesky measurement formulas that you might find that you need. So example 5. A rectangular paddock shares one side with an existing fence. A farmer has 1,300 metres of fencing material to build the largest additional fenced off area possible. Calculate the dimensions of this new area. So let's start with step 1 of our how to solve an optimization question process. And in step 1 we're going to do a diagram to represent this situation. So here is my existing fence. These types of questions are really common. Now on my existing fence I'm going to add some detail, and that is my new fences. So there and there, and it's rectangular, which I've done, and it's got a perimeter It's rectangular as shown, and it's got a perimeter of 1,300 meters, and that's represented by X, X and Y. So what I'm saying now is, and this is step 2, let X equal the width of my paddock in meters and let Y equal the length of my paddock in meters. Let P equal the perimeter and let A equal the area. And so the perimeter is in meters, whereas the area is in meters squared. Now what we're trying to do is calculate the largest additional fenced off area possible. So we're trying to maximize area, and I know that the area is equal to X times Y. That's how I calculate the area. But I can't do any optimization until I've got area as one other, or the function of one other variable. So now we start step 3. So in step 3 I'm trying to find area as a function of X or Y. Now I can't in this case, but I can set up the perimeter. Another relationship. The perimeter is equal to 2X plus Y, because I don't need to develop that fence there, that's already there. So 2X plus Y, and that means that 2X plus Y is equal to 1,300, which means that Y is equal to 1,300 minus 2X. And that's good enough for me. I can use that information now to eliminate the Y from my area. So that means that area is equal to X times Y, which is X times 1,300 minus 2X. I've just taken what Y is equal to based on my perimeter relationship and remove the Y, replace it with what it's equal to. Now I've got area in terms of X only. I expand this, 1,300X minus 2X squared. Comes out as a really simple quadratic, and now I can determine dA dx. So this of course is now step 4. Once I've got the area, the thing I'm trying to optimize as a function of just one other variable, I can now go on and find dA dx by deriving, and this will be equal to 1,300 minus 4x, and I'm going to let dA dx equals 0 because that's how I find a minimum and maximum, and so I get 1,300 minus 4x equals 0, which leads to x is equal to 1,300 over 4, which is equal to 325. Step 5, which I always do over on the side here somewhere, is to check the nature. This is a nice easy function to derive, so d squared a dx squared is equal to negative 4, which is always negative, and therefore this is a maximum because the second derivative is negative at every point. And step 6 is to put this back into context. So step 6, if x equals 325, then y is equal to 1,300 minus 2 times 325, which equals 650, and therefore my maximum area is 325 times 650, and that maximum area Well, actually, what does the question say? Calculate the dimensions of this new area. It doesn't even ask me for the maximum area, so make sure you go back and read the question. The dimensions are 325 by 650. And that kind of makes sense. A farmer might not really care as much about how much space they've got, as long as they know that they've maximised their space and where they need to put the fence up. Mathematically and procedurally for them, that's the most important thing. So there we have it, example 5, video 5. All the best.